Hi and hello to everyone. In this video, we are going to learn about the nodal analysis, particularly when you have a voltage source. This method is also called as super node analysis. So, in this problem, the question is determine the nodal voltages. Okay, so we have to find what are the nodes available, right? First thing we will find the nodes, right? If you see what is a node, when two or more elements are connected, that corresponding point is called the node. So this is a node, this is another node, this is another node, this is another node. Okay, so this node is called the reference node, or also it's called as ground node. The other nodes, let me say this is the node 1, node 2, node 3. The corresponding voltages are, let me give the name V1, the voltage is V2, the voltage at this point is V3. Okay. The question is, we are going to find the nodal voltages V1, V2 and V3. This is the question. Okay. In this case, we can identify the voltage sources as two types of voltage source exist in this circuit. One is the voltage source 10. If you take the voltage source 10 volt, which is between the node 1 and the reference node. Okay, right? Node 1 and the reference node. And the this, let me say, this is the first case, the voltage source between non-reference node and reference node, right? In this case, it's very straightforward. We have assumed the voltage at the node 1 as V1, right? So voltage at the V1 between the point here and the ground here is going to be 10 volt. Okay, so it's straightforward. That is, when the voltage source exists between the non-reference node. So this is the non-reference node, this is the reference node. The voltage is going to be straightforward. It is obviously 10 volt. Okay, then what about the another voltage source which is between two nodes, that's 5 volt. If you take the 5 volt, where does the 5 volt exist? The 5 volt exists between the node 2 and node 3. So this voltage at this point is V2, the voltage at this point is V3. In this case, the voltage source exists between two non-reference node. Okay, in this case, this is a non-reference node, this is another non-reference node. Okay, right? So in such cases, when in these cases we have to use a concept called super node. So what is a super node? Super node is straightforward. This entire voltage source of 5 volt can be considered as a single node. Okay, right? So I can make a mark here. You can see this voltage source that is existing between two non-references node can act as a super node. Okay, this entire thing is going, this is your super node. Okay, we can apply the Kirchhoff's current law for the super node as we apply to a simple node. Okay, now let us assume the current direction. Let us assume the current direction as this current, let me give the name I1, this current, let me give the name I2, this current, let me give the name I3, this I can give the name I4. Okay, right? Now we will apply the Kirchhoff's current law for the node 1, KCL at node 1, right? If you look at the KCL at node 1, right, this is the node 1, this is the node 1, right? So it's obviously V1 is going to be 10 volt. This is between these 2 points, it's going to be between these 2 points, the voltage is going to be, that is your V1 is going to be 10 volt. Okay, right. Then we are going to apply the Kirchhoff's current law at the supernode. What is the other node? Other node is your node 2 and node 3. Together they can be said as the supernode. Okay, so we are going to apply Kirchhoff current law at the supernode, right? Coming back here, what are the supernode which is between the node 2 and node 3? What are the current entering? The current entering is your I2. Current entering is your I2. Okay, and what is another current entering? I1. Okay, that is entering the supernode. What is supernode? It is between the node 2 and 3. What are the current leaving? I3 and I4 are the current leaving. Okay, so applying Kirchhoff current law at the supernode, I can say the current entering is I2, I1 and I2. The leaving currents are I1 and I3 and I4. So I1 and I2 are entering the supernode. I3 and I4 are leaving the supernode, right? Now what is I1? What is I1? Yeah, you can see it here. I1 is the current flowing through 4 ohms. Okay, what is the potential difference? If you look at the 4 ohms, the voltage at this point is V1, the another end is V3, right? So I can draw it separately. For 4 ohms, the voltage at this point is V1, the another end is V2, the current is flowing is I1. So if I take I1, it is the potential difference. So it is V1 minus V2 by 4. So V1 minus V2 by 4. What about I2? What about I2? I2 is the current flowing through 2 ohms, right? The 2 ohms is existing between the two voltages V1 and V2. Okay, so I can draw it separately. 2 ohms. The one side the voltage is V1, the other side of 2 ohms is V2. The current is your I2. Okay, so what is the potential difference? I2 is equal to V1 minus V2 by 2. Right? Now what about I3? Coming to the next question. What about I3? I3, yes. I3 is the current flowing through 8 ohms. Right? So I can draw it separately again here. 8 ohms. This is my I3. The voltage at the here is V2. The voltage at the bottom is the ground, 0 volt. Okay, so I can simply say I3 is going to be, the potential difference is V2 minus 0. Okay, the other end the voltage is 0, right, divided by 8. So it is V2 by 8 plus. What about I4, which is the current flowing through 6 ohms? 6 ohms, right? So I can write 6 ohms. This is V3, the other end is 0 volt. The current is I4. So your I4 is going to be V3 minus 0 by 6. V3 by 6. Right? So try to take LCM, right? So this side it would be 4 V1 minus V2 plus 2V1 minus 2V2 equal to, the LCM would be like 24. So it is 3V2 plus 4V3. Okay, this 24, and I can simplify, like in this side it would be 3V1 minus 3V2 by 4 is equal to 3v2 plus 4v3 by 24. So 4 and this will be 6, bring 6 to the left side. So it is 18v1 minus 18v2 equal to 3v2 plus 4v3. Okay, so bring all the terms to the left hand side. It was going to be 18v2 minus 3v2 minus 4v3 is equal to 0. So it's 18v1 minus 21v2 minus 4v3 is equal to 0. Right? Okay. So let me give the name. This is equation 1. Okay. We found out in this case the V1 is going to be 10. Okay. Between the voltage sources between the non-reference node and reference node. So V1 is going to be 10. V1 is going to be 10. This is the second one, 10 volt. Then what about the third one? Between non-reference node, right? The 5 volt is between the nodes 2 and node 3. Both are non-reference node, right? So what about the voltage? Between these two nodes, the voltage is 5 volt, right? So can I write this as V2 minus V3 as 5 volt, right? So that's the equation 3. So V2 minus equal to 5. Okay, better not use unit here, right? You're going to substitute. Okay, so this is your equation 3. Now you keep solving the equations. You should be getting the voltages, right? A substitution. Okay, so substitute V1 in equation 1. It would be 18 times 10 minus 21 V2 minus 4 V3 equal to 0. So it is minus 21 V2 minus 4 V3 is going to be minus 180. So it is 21 V2 plus 4 V3 equal to 180. Okay, let me say this is another equation. So solve the equation 3 and 4. You should be getting the nodal voltages V2 and V3, right? Is this okay? Yeah. Now we'll go into another problem. Solve equation 3 and 4. We will be getting V2 and V3. Okay. Let us take another problem. Yeah. Okay, the question is find the nodal voltages. Find nodal voltages, right? The nodal voltages are this. So this is a node. Let me give the name V1. This is a node. The entire thing is a node. The nodal voltage is V2. This is a reference node. The nodal voltage is going to be 0, ground. Okay, the question is to find the voltages V1 and V2. Okay, now you see, does this circuit have a super node? Yes, you can clearly see the 2 volt the 2 volt is between the node 2 and node 1, right? So obviously you can write V2 minus V1 as 2. This is the equation 1. Okay, so this is the super node. This is the super node, right? So let us assume other currents, like the current flowing through this is 2 ohms is I1, this 4 ohms, let me put the name I2, this 10 ohms, let me give the name I3. Okay, so this is the super node. The super node is between the node 2 and 3, sorry, node 1 and 2. Okay, so this is the node 1, this is the node 2. Okay, so if I try to apply the Kirchhoff current law at the super node. Okay, what are the current entering? 2 ampere is entering. Okay, 2 ampere is entering. Okay, then if you look at the I3, the current I3, it is entering the node 2. Okay, you see here your I3 is entering the node 2. Okay, so your 2 ampere, so this is 2 ampere is entering the node 1, and the current I3 is entering the node 2, right? What are the current leaving? I1 is leaving. Okay, I1 is leaving the node 1, and I2 is leaving the node 2, and this 7 ampere is also leaving the node 2. Okay, in the super node, that is, what is super node here? Both node 1 and node 2 combined, right? Now keep writing find the current I3. What is I3? This is and yeah, what is the current leaving? Yeah, if you look at the node 1, your I3 is in the node 1, I3 is leaving. Okay, so you have to write I3 is also leaving, right? I3 is leaving the node 1 and entering the node 2. So this is the leaving I3, this is entering I3. So these two will get cancelled out. Okay, so it's going to be 2I1. What is I1? I1 is the current flowing through 2 ohms, right? So 2 ohms, this is I1. The voltage at this point is V1. This point is going to be 0 volt, right? So I1 is going to be V1 minus 0 by 2. What about I2? The current flowing through 4 ohms. The voltage at the top is V2 minus 0 by 4. Okay, plus 7. So bring 7 to the left side. It's going to be 2 minus 7 equal to V1 by 2 plus V2 by 4. So it's minus 5 is equal to same as 4. So it is 2V1 plus V2. So 2V1 plus V2 is equal to minus 20. This is the equation 2. So 2 equations, 2 unknowns. This is the equation 1, right? So V2 minus V1 is 2. V2 minus V1 is equal to 2. This is the equation 1. By substitution, we can say what is V2? V2 is going to be 2 plus V1. Plug the V2 here. So 2V1 plus, in place of V2, you put 2 plus V1 equal to minus 20. So it is 3V1 is equal to, bring 2 that is minus 22. Minus 22. So V1 is going to be minus 22 by 3 volt. Okay. So V1 is this. We know that V2 minus V1 is going to be 2 volt. So plug the V1 here. So it is minus, this another minus 22 by 3, going to be 2. So it is V2 plus 22 by 3 equal to 2. So V2 is equal to 2 minus 22 by 3. So it is 6 minus 22 by 3, which is 6 minus 22 by 3, which is minus 16 by 3 volt. That's your V2. Okay, so we got it. Okay, one more problem, the third one. I'll give the idea. First you have to identify, first thing you have to identify what is the node, what is the super node. Then for the entire super node you have to write the Kirchhoff's current law. That's it. So how many variables you are going to solve? You should have those many equations. So 3 variables means 3 equations. That's the point. Okay, so look at the problem. How many nodes we have? We have a node here, we have a node here, we have a node here. This entire thing is a node. Okay, this is the reference node 0 volt. So let me assume the voltage as V1, this voltage at this point is V2, this point is V3, right? Where the voltage source exists, we have 2 voltage sources. The 14 volt exists between non-reference node and this entire thing. What is this entire thing is reference node 0 volt. Okay, right? So obviously the first one would be V1 would be 14 volt. Okay, what is this? Where is supernode exists or not? Yes, supernode, that is the 6 volt, is existing between the node 3, the voltage is V3 at that point, the node 2, the voltage is V2. So obviously V3 minus V2 is going to be 6 volt. This is the equation 2. Okay, now this is the super node. The voltage source exists between 2 non-reference node. This is the super node. This is the super node, and you can assume the current direction like this. Any arbitrarily we can assume the direction. Let me assume, yeah, this way: I1, I2, I3, I4. Okay, so apply KCL at super node. Okay, apply KCL at super node. What are the current leaving the super node? The current leaving the super node is I1. The current leaving the super node is I2, I3 and I4. So I1, I2, I3 and I4 all are leaving is equal to 0. What about I1? The potential difference. Okay, for 4 ohms the voltage at this point is V2, here it is V1. So it is V2 minus V1 by 4. For I2 it is going to be V2 minus 0 by 3. For I3 it is going to be V3 minus 0 by 2. For I4 it is going to be V3 minus 0 by 6 equal to 0. Okay, so write the equation. This would be your equation 3. So 3 equations, 3 unknown. You will be finding out your what is your V1. V1 is obviously 14 volt. V2, if you solve, you should be getting around minus 400 millivolt. Okay, and your V3 is going to be 5.6 volt. Okay, on solving these 3 equations you'll be getting, and you can also identify if the question is like find out the current I4, it would be like V3 minus 0 by 6. Someone is asking find out the current I1, it would be like V2 minus V1 by 4. That's it. Okay, right. I hope you learned something useful from this video. In the next video we will be learning about the mesh analysis and super mesh analysis. Thank you. Thanks for listening.